Welcome to Understand the Math. In this video, I'm going to go over lots of example problems for evaluating compositions of trigonometric functions. Before you begin, be sure to check out the video description below for a link to free guided notes that you can download and fill in as you watch this video. Before we begin going over the example problems, we need to quickly review the domain and cancellation properties for our trig and inverse trig functions. These sine functions, these cosine functions, and these tangent functions. Sine x is defined between minus pi over 2 and pi over 2, so this first cancellation equation will be valid when x is in that domain. The domain for inverse sine x is between minus 1 and 1, so this cancellation equation will be valid in this domain. Cosine is defined between 0 and pi, so this cancellation equation will be valid when x is in that domain. Likewise, the inverse cosine function has a domain between minus 1 and 1, so this cancellation equation will be valid between minus 1 and 1. The same holds true for tangent and inverse tangent. The domain of tangent is defined between minus pi over 2 and pi over 2, so this cancellation equation will be valid in that region. Likewise, inverse tan has a domain between minus infinity and to infinity, so for all real numbers, so this cancellation equation will be valid for all real numbers. When we go through the example problems, we'll see how all of this works. In this first set of examples, we'll learn how to evaluate compositions of the same trig function, such as sine and inverse sine. We'll first evaluate sine of inverse sine of root 3 over 2. We'll remind ourselves that the domain of inverse sine of x is x ranging from minus 1 to 1. X is equal to root 3 over 2, and this is in our domain. Because of this, our cancellation equation can be used, and we can say that sine of inverse sine of root 3 over 2 is equal to root 3 over 2. For our second example, we're going to evaluate sine of inverse sine of 2. Again, our domain for inverse sine is for x ranging from minus 1 to 1. X in this case is equal to 2, and that is not in the domain. So because of this, we say that sine of inverse sine of 2 is undefined. In our next example, we'll evaluate arcsin of sine of 30 degrees. The domain of sine x is going to be when x ranges between minus pi over 2 and pi over 2. 30 degrees is equal to pi over 6, and that is in the domain. We can then use our cancellation equation and say that arcsin of sine of 30 degrees is equal to 30 degrees. Our fourth problem is to evaluate arcsin of sine of 3 pi over 4. Let's again write down the domain for sine. That is between minus pi over 2 and pi over 2. X is equal to 3 pi over 4, and that is not in the domain. So what we have to do is find an equivalent angle to 3 pi over 4 that is in the domain of sine x. The first thing to do is to plot our angle, which I've already done here in purple. Our angle is 3 pi over 4. Since the domain of sine x is between minus pi over 2 and pi over 2, our angle needs to be in the first or fourth quadrant. Sine is related to our y value, and our y value for this point is positive. So that means our equivalent angle must be in the first quadrant where y is also positive. We can think of the angle 3 pi over 4 as pi over 2 plus pi over 4. So our equivalent angle in the first quadrant is pi over 2 minus pi over 4, which is pi over 4. We can then write that arcsine of sine 3 pi over 4 is arcsine of sine of pi over 4, which is in our domain, so this is just equal to pi over 4. If you're finding this video helpful, please give it a thumbs up and consider subscribing to my channel. Let's now look at a composition with a cosine function. Let's evaluate arccosine of 4 pi over 3. The domain of cosine x is 0 less than or equal to x less than or equal to pi. X is equal to 4 pi over 3, which is not in that domain. Because of this, we'll need to find an equivalent angle to 4 pi over 3 that's in the domain of cosine x. Just as we did for our sine problem on the previous page, we draw our angle, and we note that the domain of cosine x is between 0 and pi. So our new angle needs to be either in the first quadrant or in the second quadrant. Cosine is equal to the x value, and the x value for this point is negative, so our equivalent angle must be in the second quadrant where our x value is also negative. We can think of 4 pi over 3 as pi plus pi over 3. So this point is pi minus pi over 3, which is 2 pi over 3. We can now write arccosine of 4 pi over 3 as arccosine of cosine of 2 pi over 3, and that's in the domain, so this is equal to 2 pi over 3. Let's now look at a composition with a tangent function. We'll remind ourselves that the domain of tangent x is x goes between minus pi over 2 and pi over 2. X is equal to minus 5 pi over 6, and this is not in our domain, so we'll have to find an equivalent angle to minus 5 pi over 6. The domain of tangent x is between minus pi over 2 and pi over 2, so our equivalent angle needs to be in quadrant 1 or quadrant 2. Tangent is positive in quadrant 3, where our point is located, so our equivalent angle needs to be in quadrant 1, where tangent is also positive. Since tangent has a period of pi, we can think of our new point as minus 5 pi over 6 plus pi, which is pi over 6. We can then write arctan of minus 5 pi over 6 as arctan of tan of pi over 6, which is in the domain and allows us to use the cancellation equation. So this is equal to pi over 6. Hang in there. We only have 2 more examples. I know this is hard material, but you can do this. These next 2 examples involve compositions with different trig functions. For our first example, we'll simplify the arcsine of cosine of pi over 3. To simplify a composition like this, we're going to work on the inside function first. This is the inside function. We know that cosine of pi over 3 is equal to 1/2. We'll then work on the outside function. Arcsine of cosine pi over 3, which we found to be 1/2, is an angle which we'll call theta. Since 1/2 is between -1 and 1, we can say that sine of arcsine 1/2 is equal to sine of theta, or 1/2 is equal to sine theta. Sine theta is going to be equal to 1/2 when theta is equal to pi over 6. So this means that the arcsine of cosine of pi over 3 is equal to pi over 6. Our last problem is a little bit complicated, but I'll go through it very carefully so that you can understand it. Just like we did for the first problem, we're going to work with the inside function first. Our inside function is an angle, so we're going to let theta equal inverse sine of -8 over 17. This means that sine of theta is equal to -8 over 17, because -8 over 17 is between -1 and 1. We now need to find the quadrant where theta is located. The domain of sine theta is between -pi over 2 and pi over 2. Sine theta is negative, so that means that it must be in quadrant 4. We're going to draw a triangle in our fourth quadrant. It doesn't matter if the triangle is to scale or not. We're going to include our angle theta, and we make a note that sine theta is -8 over 17, and we know that sine is opposite over hypotenuse. So our side opposite theta is equal to 8, and our hypotenuse is 17. We're now going to work with our outside function, which is tangent. Tangent of inverse sine of -8 over 17 is now equal to tangent theta. Tangent of theta is equal to the opposite side divided by the adjacent side. When we look back up at our triangle, this is equal to the opposite side up here, which is -8, divided by our adjacent side, which is x. We can find x using the Pythagorean theorem because our triangle is a right triangle. So the Pythagorean theorem states that x squared plus 8 squared is 17 squared. This gives x squared plus 64 is equal to 289, which gives us x squared is 225. When we take the square root of both sides, we get x is equal to 15. We then plug that back up into our answer, and we find that tangent theta is -8 divided by 15. These problems are very difficult, so I would suggest that you go over them again and work through them until you can do them on your own. Mastering these types of problems just takes a lot of practice.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.